Good afternoon, everybody. Am I audible? So, welcome to Intel Tools Training. This is the third event from our club. So, before we start, I will tell you about our club. So, let me present my screen to you. Is my screen visible? So, as you all know, we are the newest club in our college, along with the CodeChef CMRTC chapter. So, our club is Intel IoT Club. So, this club works under guidance of Intel, and we follow whatever Intel tells to do to us. And let me tell you about our club. So what happened is Intel started planning that we can't get connected to various students of various colleges. So what we should do? Once again. So they told that how can we connect to various students and clubs and colleges? So they came up with an idea that they had in US. What they did, they started having many clubs in various colleges across United States. But in India to connect, they were having a little bit trouble because the people connections weren't good actually. So they started the program in which they started enrolling various colleges, students to join this. And with this, they started enrolling us. So they started little bit around six colleges in each batch. They covered various colleges across Hyderabad, CMRIT, CMREC. And in the seventh batch, our college was there. So I got selected. Then we started the club. So our time, one second. So on 17th December, we got selected. On 25th, we got permission to start our club. On 28th, we started an enrolling process for our club. After that, following on 10th Jan, we got selected to our core team members. And on 13th, we had the formal induction. So we are around five in our club. On 23rd, we have an event called as Tech Connect. It was a event for the second years. On 30 Jan, we had an event for the first years. So it both are the event. This is our third event for the third years. So what activities do our club performs? Our club performs mainly three activities. That are we will conduct various sessions. We'll have various hackathons, and also we will keep sometimes contests also. And the three main domains which we deal with are AI, ML, and IoT. So we have AI head in our club, that is Bhavna. She's in second year. ML head, that is Yashraj. He is in third year. And IoT head, that is Arun Deepak. He's in third year. So let's begin with the session. So today we will be having two tools. One is the OpenVINO tool and the second one is the Devcloud. OpenVINO tool is mainly for the optimization of our models and various things. So let me explain you about OpenVINO first. So as we all know, artificial intelligence is changing various industries. It might be even emergency responses, energy. Every industry, artificial intelligence is present. So deep learning is the fact that is AI inference. That is, we don't need to provide any data. The model automatically learns with the help of neural networks and predicts whatever is there. It is a very big industry, around 52 billion. It will be there by 2025. See, you can see the graph how it has grown rapidly. In the COVID times also it has grown very rapid because increase in usage of various hardware, software, etc. So why do we need deep learning? Deep learning is needed because humans can't be accurate every time. But when a model does this, it is 100%, mostly around 90 to 100% it is accurate. For example, if you see a person far away, you can't identify him, but if he is near you, you can identify easily. But with artificial intelligence, machine learning, various things, we can identify very easily. Have you I think most of you might know, be knowing Alexa and Google, right? They simply get the song lines, and they can easily predict what is the song is. So this is also a very big industry. This is around 13 trillion industry. So this is DeepSight. That is one company who makes things. For example, a tire is there. It can identify from the camera sensors that the tire might not be good and might not be able to withstand various things. So it gets rejected. Just in few seconds, this process occurs. In medical field also, they are there. In aquatic regions, we can't go where we can't go. These things are possible. See, in the space also, humans can't go to a distances that is millions and millions away from the Earth. So we need various machine learning, AI, and everything. So how the cycle works? The cycle is basically it contains of four steps. The first step is that is we import the data acquisition and organization. First, we acquire the data. I think CSE students might have covered artificial intelligence, and even EC students might have covered IoT. So you might know data acquisition is important first. Then we organize the data. Unnecessary data is removed. Then we create a model. Then this model is trained based on our requirements. All the performance and accuracy objectives are taken care of. Then the next step is we deploy these models. For deploying these models, we need hardware, right? That is the CPU, VPUs, etc. So this is how the deep learning cycle is working. So there is a very important difference which we would like to point out. What is the difference between the training and inference? You might have heard that we are training a model, people might be saying, right? In that, what happens is they provide them with images, labeled data. For example, a human photo is provided and it is labeled as human, so the machine can guess next time whenever it sees a human, that is a human. But inference, what happens is you just provide the image, it inferences automatically with the help of various neural networks and tells us what the actual thing is. One thing that happens is in training, once a new thing has occurred, it needs to traverse back to the data which it has collected and check what is there or not. But in inference, automatically the network checks and tells you. So no going backward is there, because we can't provide every data. So inference is also very crucial for us. So what do we need for artificial intelligence compute considerations? So there are mainly three things: workloads, how much data, how much load we are going to put on that model. For example, if a traffic light is there, one second. Yeah, if traffic is there, right? If at a signal we stop for 10 minutes, then there would be huge traffic behind that. But when we leave it for one minute, there would be no traffic jams and no issues. And the second thing is requirements. We need to know what are the case requirements exactly, because uh, if we don't know the requirements exactly, the model would be incomplete, and it is a totally wastage of time and resources. Then demand. So what is the demand? CPUs demand, GPUs demand, various hardware's demand is also required to be considered. See, three challenges are there. Unique inference need. In this, what happens is we can't exactly put what a model needs to do. So every model is unique. Here also we can see that no one size fits all. For example, if you are making an artificial intelligence model for knowing the facial recognition, it can't be used to know various details such as his motion and everything, right? So we need separate model for separate things. And one more challenge is the integration challenge. We can't integrate models with directly into our application. We need to go step by step in order to integrate it. So what does OpenVINO tool do? Whenever we build a model, it is directly deployed into various platforms like Windows, Linux, and Macintosh. But what happens is it takes a lot of time. So whenever do something, it takes a lot of time. So what this OpenVINO does is it converts and optimizes model such that on Intel hardware and environment, it will provide in a faster and efficient way. For example, if you are having an i3 or i5, Intel OpenVINO tool will already be knowing what are the requirements, how do we put it such that the performance is high and it is computed very fast. So this OpenVINO tool is used across various industries such as industrial levels, health and life sciences, retail, safety and security. Because whenever we need safety and security, we need a fast rate. Quicker response is more important. So what is the compounding effect? Tiger Lake is basically the 12th generation of Intel CPUs. What happens here is when we use a normal one, we have a 2x efficiency, but we try to optimize, we can only get up to 2.1x or 2.2x. But with the help of Intel toolkit, OpenVINO toolkit, we can optimize it up to 3x or 2.9x, etc. So because this knows how the hardware is and how it is made for the best and better performance. So this is how a developer journey is. The first thing it does is basically it builds, then we optimize, then we deploy. See here you can see that the first thing which we do is we build the model. These you can think as IoT models or AI models, various models. Then the trained model is deployed on various things. That is, we can use the TensorFlow, Cafe model, or the MXNet model. These tools are used. Various models are used. Then this model is directly sent into the optimizer. Model optimizer then converts the trained model into threads like thing, and it separates in two parts. That is, one is the XML file and the bin file. XML deals with the data, then it is sent to inference engine. This inference engine is very capable and knows how what exactly to be done, thus reducing the time. Then we can deploy it on anything. We can deploy it on servers, we can deploy it on hardware, we can deploy it on VPUs, CPUs, GPUs, etc. So this is how basically the OpenVINO works. It is an outline from a model, then it optimizes it, then it deploys on various platforms. These are open models used. These five are already available on OpenVINO. That is the TensorFlow, ONNX, and Kaldi, MXNet, Cafe. These all models are previously defined in OpenVINO and does not need to be defined again. There are some models which are not defined, that models don't directly work, but we can integrate them. In the OpenVINO, we have around 280 plus pre-trained and optimized models, which you can use for your creation and development purposes. See, what is this model optimizer? It is based on Python. Python you might be comfortable at because it is used everywhere, right? Python, so it is very excellent to use Python on this. So it imports various trained models, then converts them into immediate representations. This then optimizes for performance and space with conservative topology transformation. So it knows right how it should be done and where it should be done. It is mostly the OpenVINO toolkit is based on hardware. There is not much to do with the software. Whatever you make, it optimizes for the hardware and then deploys it. See, these two are there, that is XML and bin file, which are converted from your model to deploying purposes. So here you can see what is post-training optimization tool. It is a conversion technique that reduces model size into low precision without retraining. You don't need to train again and again because already you have trained, right? This will save your computational power and save various resources. This also decreases the latency and degradation of your model. IR is the immediate representations. So from train model, the optimizer converts it. Then full precision IR is there. This then goes to the optimization tool with checking accuracies and various environments. Everything is done and that is deployed. So we have the deep learning workbench as well, which is easy to use than the actual OpenVINO toolkit. An inference engine, as I have told about deep learning, it is an extension to what deep learning does. It needs a inference engine, right? High level C++ or Python inference runtime API. API is the application programming interface you all might know about. It is implemented as a dynamic loaded plugin for each hardware type. Whenever you change the hardware, right, from i3 you go to i5, dynamically the new plugin is automatically installed. You don't need to do anything, and then you can deploy it. So the OpenVINO toolkit has this feature that we write once and deploy anywhere. Because writing once is the hard work, then deploying is very easy. So this is the topology for application, then application to the API to multi-device plugin. Then this multi-device plugin has can be sent to various devices. For example, if you are using Intel CPU, it can be sent to Xenon, Atom, everything. If you are using VPUs, the GPUs, that is Iris, various things. And Modulus API is for the VPUs, virtual processing units, that is video processing units. So there are more tools available on this. So you can see some case studies are given where it is used. For example, Samsung collaborates with Intel to speed nerve detection and improve workflows. Hitachi uses AI to speed visual inspection and reduces human error. So these are some fields where this tool is used for instant results. So you can download this tool. We will share you the link. Now let's go to the second tool for today. It is the Intel Devcloud for Edge. Previous one was for optimizing the solution, right? Now this Devcloud does is we can optimize directly. So I will tell you about it. So accelerate text cycles with Intel Dev for Edge. What you can do is you can prototype your model, then you can benchmark on various applications, then you can run AI application from anywhere in the world because these applications are not there on your computer locally. It is present on the cloud itself, and thus you can save the development time and cost. So this is how it is done in the cloud. You can deploy and scale your models. Yeah, this is the steps. First, you need to access the DevCloud. You can create your user ID, various things. Then you can develop and test applications online using GitHub. You can import the GitHub libraries, various things. You can upload your data sets from your local computer. Then you can test your sample code. This everything is done in HTTP request, so it is secure for you. This is what happens is on the cloud you have been allocated 50 GB of data for every 30 days. So in that data, you can upload all the data sets and various things. This thing would be running on the Intel's cloud platform. Then you can get the results on your computer. So let's build something. So this is the page how it looks. You guys need to enroll here. You can click the enroll button over here and directly enroll in it. Then already I have account, so I will just sign in. So this is the console. You can get to know about this OpenVINO and Devcloud in the console itself because both are integrated here. They share about details about various things directly into this. So you might be knowing Jupyter notebooks, right? It is used to execute Python codes. It is directly integrated into this. Here you can see various environments are there present and everything is there. So what we do is we use the one API because one API is the Devcloud name. So here you can learn about various things, that is how do you deploy on things, etc. So in this console, you can see we have the home screen where product updates are being given. We have the second screen where we can learn various things. Third screen is the build screen, which will direct you to the Jupyter notebooks, Jupyter environment where you can create and connect your notebooks already existing. And optimizer, right? You know, OpenVINO, right? That is directly integrated, so we can optimize our thing also directly here. Then you can launch also your thing. So what we are going to do is we will build one application. You don't need to know programming very deeply to use this. It is easily available to learn and understand. So I have created clicked on build. Then here I have AI sample applications. In the sample application, we have around 32 already trained models are there. So let me go with robotic gear, safety gear detection. As this is placed on Intel cloud, right? It takes little bit time. So this Jupyter page has loaded. We have selected safety gear, right? So it loads all over the whatever the required files are there. For example, the video, everything. Code is also present here. You can go through the documentation and easily understand various things, how it is working, what is the model we are using, how are we inferencing it. Everything is there. So what are the extensions we are going to use? So then what happens is this is the shell, right? In this, you can directly execute the code. First, we need to import mainly various libraries, that is Matplotlib. This is Python based, so everything would be in Python itself. So it has imported everything. Then what we can do is we can go through the entire code. Then what it does is then it builds various detection models, IR files, immediate representation files. So there are two immediate representation files, that is FP16 and FP32. So it is building, it will take little time. We are going to use cafe model here. So it is dot cafe extension. So it has executed. Then after we have done that, then we will check whether it is working or not. We can open the graph, but it will take little time, so we can leave it. We'll go with it. Then what we'll do is now we'll run inference. This will run. So this is the video which we are going to use for our model purpose. So a lady walks by, she is wearing safety gear, but we the model don't know what is she wearing or not. So we'll build boxes around it using various TensorFlow or various libraries. This is the job file. When we submit the job to the cloud, on the cloud this starts running. After we are done with it, we select an Intel CPU we want. For a purpose, you want on a normal Intel CPU, you want E3. All the architecture is previously present here because it is optimized for it. Then it starts pre-processing, inferencing, and rendering. It takes little time based on the CPU you have selected. So it is loading slowly. We need to select only one. If you want, you can go for others also. But for current demonstration purpose, I would be only selecting one. So we can see here the pre-processing took around 14.7 seconds. Inferencing took 10.7 seconds. So it has inferred and understood whether she's wearing a helmet or not. Other things. Pre-processing is the loading of the video and checking about the video. And rendering is after providing an output like thing. So it has taken around 23.1 seconds to render. Now we can go directly downwards. You can monitor the stats over here. See, this is the safety gear. It is in queue. Once we are done with it, we will just simply run this. And what happens is here the video gets pre-processed. The same video which we have loaded earlier can now detect the safety gear, whether she is wearing vest, helmet or not. Everything can be detected easily. So she is not wearing. wherein so it detects error, right? So you can execute more and understand various models that are previously present here. So this is all about Devcloud. Just a second, let me. So the final step you guys need to do is you guys need to take a small quiz in order to get a certificate. So this quiz is hosted by Intel. You guys please enter your name, university, unique ID we will be providing to you. The training date is 19th. You can select the 19th date here. Whenever you fill only 19th date. Then you can start. It would have around 10 questions, which you will be given three chances. In this three chances, you need to score at least 70%. That is, out of 10, 7 of your answers need to be correct. So let me just fill randomly. So it is telling only 50% of your responses are correct. You need to get at least 7 correct. You have 3 attempts. So once you do this, Intel would be issuing certificates to you guys based on this tool training and everything. So that is it, guys. What any doubts we are ready to answer. Anybody has any doubts? So the test link we will be providing in the WhatsApp group, such that the people who could not attend also can use this and get certificates. Everything, the tools link and the test link, everything would be provided in the WhatsApp itself. Anybody else? If nobody is there, let me close this. Thank you guys for joining the session. We'll have more of a fun-filled session soon. We have reduced the session size from 2 hours to just 1 hour because we don't wanted to waste today's exam. So we have excluded our AI, ML, and IoT topics. Only tools have been covered. Thank you.